Hello, my name is Chen Kai, and my final project topic was on Azure Machine Learning Service. So, with Azure Machine Learning Service, there's quite a lot of different technologies that Azure Machine Learning provides, um, and they offer cognitive service as well as some API level consumption for stuff like image recognition, facial detection, and ready to use out of the box APIs. But they also have tools for data scientists to experiment. Um, One tool that they have online is called Azure Machine Learning Studio, which is a web app that allows you to import your data, run experiments in the cloud using the compute resource, and kind of get results through this very user-friendly drag and drop GUI interface. Um, and for my project, I decided to explore what was recently released tool called Azure Machine Learning Workbench. So this is a desktop application for Azure Machine Learning and Big Data Analytics. So it's an integrated environment designed for data science experiments. So to start with, this website here um, has instructions on how you can install Azure Machine Learning Workbench. Um, and there should be a link for a Windows installer here, as well as a Mac and DMG to install. So I already have it installed here, so I'm going to open this application. It's still in preview right now, so it just came out about 2 months ago in September, so it's fairly new, and there are bugs in the software, of course, and there are some frustrating issues I ran into when I try to use the software that were kind of frustrating, but I'm sure that will get better as it gets more adoption and new updates comes out. So when you first open this application, um, there's some what's new tutorials and things for you to get started with. When you attempt to create a new project, it's got a whole bunch of different templates here to kind of show you some of the um, capabilities that it allows. Here we have classifying iris, just a pretty classic data science experiment, simple linear regression. They also have this MNIST dataset for classifying handwritten letters using TensorFlow, as well as using Microsoft's cognitive toolkit, which is basically Microsoft's abstraction for a deep neural network framework, as well as MML Spark, which is also Microsoft's version of Spark on some sample data. There are some other stuff like Q&A matching, data analytics, biomedical entity recognition. Some of these things are quite interesting, and you can kind of get an experiment that's already pre-built out of the box for you, so you kind of get the gist of how to set things up. So let me first, since we're demoing Azure technology, let me first show you one of their sample projects for Microsoft Machine Learning Spark. Um, so as you can see here, you also get a Jupyter Notebook integration as well as some scripts that is set up in the default project. So here you can see there are scripts for running your project in either Azure Machine Learning Spark or regular Spark using a Docker container. So let me just open my project. So the project that I did um, is predicting airline delays. So the goal of my experiment was to given a open data set, and this is what my data set looks like. It's got a whole bunch of data on airlines, delays, air flight number, destination, origin, schedule time, and my goal is, given this data set, can I predict how likely a flight is going to be delayed by more than 15 minutes. So basically this is the data that I imported here. So basically, let me just show you what it looks like when you want to add a new data source. You say I want to point to a file, and you choose a number of different formats. In this case, is CSV, and it automatically detects all these rows and asks you kind of how to format it, as well as it automatically detects the data types that your data is in. And next, this is what I found to be quite cool. You can sample your data. So, for example, if you had a data that's like half a gig and you don't want to use a full data set right away, you can sample. There's a number of different strategies here: random, percentage, random n, or you can pick the full file. And later on, you can always come back here and change the sampling to turn it off once you have a good confidence that your parameters and your whatever algorithm you're using is correct to train it on the full set. I'm not going to import it because I have already imported my data here. And here you can actually see, you can also you could visualize your data as well. One column that's quite cool is the number of missing values. Here you can see what values are missing from your data, so you could potentially clean out columns which are missing lots of data. So once you have the data imported, you could prepare your data by processing it by clicking the prepare button, which I already done here. So for example, here I have a whole bunch of columns that I know is not going to be useful for my experiment. For example, the wheel off, lapse time. A lot of these rows are really not useful for me. So I want to definitely delete some of these rows. And you can do that in this data preparation step here by right click. You could do stuff like remove column. Here it shows how these are tracked now. And later on you can always delete the steps. You can undo certain operations if later on you want to put that column back without actually modifying your data. So the steps are undoable, which is cool. Another thing that I found that's quite useful is kind of being able to bucketize your data here in line. So normally, you have to categorize your data in code. If you have some data that you want to turn to buckets, you can actually do that very easily here. So for example, if I have arrivals, right, with a whole bunch of data, varying values, but I want to put these into buckets. What you can actually do is right-click, derive column by example. Here you basically tell it, you give it a few examples, and it will generate a column based on that. So for example, if I want to bucketize these by their values, so say if I want a bucket that's from from -22 to -15. Actually, this might not be a good example. Let me do one from 0 to 10. So if I say 5 should be from 0 to 10. So now it wants some more examples before it. Well, no, you see some of these values already filled out. So it wants to know what about -9. -9 should be between -0 to -1. And here it's quite confused because yeah, it's quite confused here because I think the negative signs it's getting confused. But basically, in theory, you should be able to bucketize these just by giving a few examples. I'm not going to do it here because I think it might not recognize the negative signs. But for now, this is how you do data preparation. Once this data is imported, you could go to your file explorer here. So for my project, I tried 3 different classifiers to get my results. I tried a boosted gradient boosted tree, a decision tree, and a random forest. All 3 of these scripts are pretty similar. The only difference really is the classifier that they're using and the parameters that is being passed in to the classifiers. So what's cool here is we actually don't have to set up any VMs because it's loaded down for you automatically. Basically, what you can do is create these Docker config files that says I want to use a base image, for example here, with Microsoft Spark already installed, and give it some dependencies, for example, I don't know, Spark version, and kind of different versions. And when you have that configured, you should be able to just execute your PySpark or Microsoft Spark project, and it will run it in isolation in a Docker container automatically, or automatically generate the Docker image, run it, and report the results. So I can show you here, we have this boosted decision tree. I could run it and target the Docker and hit run. It will actually submit my run. And what's cool is I could actually kick off multiple runs at the same time because executions are asynchronous. So here we also have these command line arguments that we could pass in directly here. So I could say, if I want to tune my parameters, I could say, let me try one with max bin and max depth of 10, kick off another run, and just wait for it to finish. This way I could quickly tune my parameters and have all the runs be tracked. So if you look at some of these run results, you could go here, you could see the summary of all your run results. So for example, this is the decision tree results, where it shows me kind of the accuracies that I have gotten on the different run numbers and how long they take. Which is pretty cool. I got these graphs printed up for free just by using the logger that was that's included with Azure, the Azure library. Yes, so another cool thing is you could actually also set up a remote VM. So here I have a VM in Azure that's running Linux with a Docker process running. You could configure the remote VM to become a compute target. In this case, I have my VM here pre-configured, and I can actually kick off runs against on my VM, so I can actually have multiple runs going simultaneously, some local and some remote, which is great for scaling out. When you have big experiments that your local computer can't run, you can have it run in a VM in the cloud using compute resource. So, and the results of my experiment I have here, I was able to get um, the accuracies. I wasn't sure how good I could achieve, but with the different classifiers and trying a bunch of parameters, all of them kind of hover around 68, 69%. So the best I was able to achieve was with the gradient boosted tree with a parameter of maximum iteration of 128. I was able to get a 69.7% accuracy in predicting whether a flight will be 15 minutes delayed or not. So it's okay. It's not bad, but I'm not sure how high it feasibly can get. But after trying the few different experiments, different classifier, this is the maximum I was able to achieve. So that is my project. Thank you.